So at this point in the unit, we've covered almost all of the integration techniques we're going to learn. Let's do a quick overview of what we've seen so far. We started with basic integration in section 8.1, right? Those were just the things we could find on the formula card. We moved on to integration by parts and tabular integration. Then we did trig integrals and trig substitution integrals. And finally, in the last section, we did partial fraction decomposition. So at this point, we're really ready to start using this flowchart. So whenever you start seeing an integral, I want you to start moving through everything on this table and seeing which tool you can use, going from the top to the bottom. Now, we're not quite ready to talk about improper integrals, so skip over this for now, but let's just start right here and start moving through to see if we know how to evaluate some of these guys. In this section, we're going to be learning what's called integration by tables, which is the idea that we, at some point, might just want to have a list of all the patterns we might be trying to match with an integral. Okay? But for now, let's start moving through some integrals and see if we can practice choosing between our techniques. So let's start with the integral of x ln x. And I want you to notice that all four of these examples look really similar. They involve x, ln x, and dx in some sort of different order, but each of these is going to have a very different method. So looking at x ln x, I just want to kind of go down my chart and see what I can use. So let's see. If I'm going to start with anything on the formula card, do I see anything on the formula card that matches it? No, not really. Next, do I have a product of trig functions? No. Do I see one of these guys showing up? No. Is my integrand a polynomial times a cyclical function? No. Is the integrand a polynomial divided by a polynomial? No. Am I told to use a table of integrals? Nope, not yet. So my only remaining option is to do integration by parts. So let's try that one really quick. Using Lie8, logarithmic part, yes, I do have that. So u is going to be that logarithmic part, which means dv is x dx. Okay, if I take a derivative and integrate, du is going to equal 1 over x dx, and v is going to be x squared over 2. So integration by parts tells me to do uv minus the integral of v du. That's going to be ln x times x squared over 2 minus the integral of x squared over 2 times dx over x. So in other words, x squared over 2 ln x minus integral of x over 2 dx, which becomes x squared over 2 ln x minus x squared over 4 plus c. So our first one used integration by parts. We had to go all the way down the flowchart. Our second one looks a little different, and we're going to need to decide which thing from the flowchart we can use. So looking back at our flowchart, start at the top again. Does this match a basic rule on the formula card, or just some basic technique we learned? Well, in this case, I'm thinking maybe I can just do a u substitution and do the power rule. So let's try this out. If I let u equal ln x, then that would mean that du equals 1 over x dx, or in other words, dx equals x du. So if I try to rewrite this integral using that u substitution, I've got u over x times x du, and at this point it's just the integral of u du. So it really is just going to be a power rule here. Okay, so a lot of times we just try a u substitution until something works. This one's very doable. I should just have u squared over 2, which is going to be natural log of x squared over 2 plus c. So this one was just a power rule with a u substitution. Okay, so just an 8.1 basic integration technique. Alright, let's look at our next one. 1 over x ln x. So I'm going to start with my flowchart again. Starting at the very top, does it match something on the formula card? Maybe I can do some kind of u substitution from 8.1. So let's try a u substitution again. This time we're going to do, let's try u equals ln x. All right, I don't know if it's going to work yet. I just want to try it and see what happens. That would mean that I've got du equals 1 over x dx, which means dx equals x du. So let's plug that in and see what happens. I now have the integral of 1 over x times u times x du. So this is the integral of du over u. Well, hold on. not only have I done a u substitution now, at this point I've got the pattern that I can match for a log rule. So this is just going to be the natural log of the absolute value of u. Okay, but u in this case is ln x, so my answer is actually the natural log of of x. Kind of a weird one, but this time we used 8.1 and used the log rule. Alright, let's take a look at my next one. X over ln x dx. Now, I'll just go ahead and spoil this one. I could go all the way down my chart. I could try every u substitution I can think of. Believe it or not, there is no nice clean answer for the integral here. Right? There's just no way to do it. If you look this up on a program like Wolfram Alpha, it's going to tell you what's called a non-elementary function. Right? They can describe how this relates to other integrals, but we don't actually have a nice answer for this. So the question becomes at some point, wouldn't it be nice if I just had a large table of the options that I might see? Right? We have a formula sheet, and that formula sheet can be convenient, but obviously this isn't every kind of integral in the world. Wouldn't it be nice to have like all the integrals we know how to do? So turns out all the integrals we know how to do is an awful lot, but your textbook has done kind of a compromise for this. So what we're going to learn in this section is how to use Appendix A in the back of the textbook to find some integrals. So just a quick primer on how to do this. If you have a physical copy of the textbook, just turn to the back and it's in Appendix A. You can look for the A page numbers. If you're in the digital textbook, hit this X to go to the table of contents, scroll down and choose, sorry, I've been saying Appendix A, I meant Appendix B. It's the integration tables. Okay, so we're going to learn how to choose between these options in the integration tables, and then use these to do some integrals. So this is like the formula card we have, but on steroids. There's a lot more different options for us to choose from, which means we'll be able to solve a lot more integrals.